All right, to all the high-end audio manufacturers, mastering engineers, and hardcore audiophiles tuning into this explainer, welcome. We're diving into an absolute paradigm shift in high-fidelity audio and digital rights today. We're literally crossing the chasm from just playing back digital files to physically recreating acoustic events.
So, think about this. What if you could hear not just the recording itself, but the actual physical room where it was made? And I don't mean as some digital reverb effect, but as a real-life physics event happening right in your living room. For decades, we've basically been chasing this high-fidelity illusion, right? I mean, sure, we capture the digital signal perfectly down to the absolute last 1 and 0, but we completely lose the physical context of the artist's original mastering room. The monitors, the amps, the acoustic strain of that specific space, it's all just tossed out. We get the notes, but we lose the space where they were born.
And honestly, that perfectly tees up the core issue we're facing today, what we're calling the high-fidelity illusion.
Because look at how traditional playback works. It basically just plays a fixed digital file, and if you want to tune it to your room, you're stuck using a one-size-fits-all DSP or EQ correction. Sure, it fixes frequencies, but it has literally zero understanding of your actual room. But CSDL enhanced playback? That flips the whole script. It reconstructs a multidimensional physical context using what's called constraint-dependent perceptual alignment. In plain English, it adapts to your specific amplifier, your room acoustics, and your speaker load to authentically recreate those original physical conditions.
So how do we pull off this kind of magic without relying on DSP? Well, let's dive into the core of this paradigm shift, CSDL.
CSDL stands for Configurational Computing System Design Language, and it is absolutely the key to this whole shebang. Now, this isn't software running on a CPU. It operates on a fundamentally different principle, relaxation instead of execution. Picture a physical hardware array, specifically an OTAC analog array. Instead of crunching code to find an answer, it actually relaxes itself into its lowest energy steady state based on a set of constraints. And boom, that steady state is the answer. It's the physics actually doing the computing, instantly.
Let's walk through this new audio journey step by step. Step 1. Recording. Right there in the mastering room, a specialized ABN-QSS chip captures a snapshot of the room and equipment's physical state. We're talking critical data like mechanical stiffness and acoustic strain. Step 2. Encoding. That physical snapshot gets encoded as a media fingerprint that's baked right into the vinyl groove or embedded in the digital file. And Step 3. Well, this is where it gets wild. Playback. The listener's system, which has its own ABN-QSS chip, measures their unique room, and then physically relaxes its hardware constraints to match the artist's original baseline. It is quite literally tuning your room to the artist's room in real time.
Now, for our engineering partners out there, let's look at the analog reproduction engineering making this happen. This is where we prove how this physical analog reproduction technology works as tangible hardware, no DSP required.
We've got what we call the engineering trinity here, 3 distinct hardware-level interventions. First up, input matching, which uses active impedance to align perfectly with the preamp. Second, that media fingerprint we mentioned, which establishes a bidirectional baseline by recording the master's physical snapshot. And third, output correction, which provides real-time damping customized to the specific speaker load. Let's break these down real quick.
Starting with active impedance matching. So traditionally, amps have fixed input impedance, right? Like 10K or 100K ohms. It forces designers into this frustrating universal load compromise. But with CSDL, the OTC array dynamically and continuously adjusts that input impedance in the analog domain based on input strain. And it does it at absolutely mind-blowing speeds, like under 50 picoseconds. There are no relay clicks, no stepped attenuators. It completely frees up the preamp's voltage potential, acting like an open circuit when high impedance is needed, or instantly dropping to match high current designs.
Next is the media fingerprint, or F-master. Let me be clear, this is not your typical MP3 metadata tag. It's a tiny 128-byte physical snapshot that precisely records the mastering system's physical parameters. We're talking mechanical stiffness, acoustic strain, phase convergence, all captured at the exact split second the artist approves the master. It can even be physically etched into the vinyl groove as an ultrasonic watermark. It's essentially a physical memory of the creative moment.
And finally, the output correction loop. The speed here is just insane, under 500 nanoseconds. The system constantly monitors the speaker's real-time impedance and back EMF directly in the analog domain. If the speaker's voice coil heats up and shifts the impedance, the CSDL engine instantly tweaks the damping factor to compensate.
If there's a short circuit, it protects the gear at the hardware level in under 500 nanoseconds. This is literally the first truly load-aware analog output ever, and it completely sidesteps that annoying latency you get with digital to analog converters. But look, this engineering doesn't just change the sound. It unlocks a massive commercial breakthrough for high-end audio IP. And that brings us to electronic artwork authorization technology. This is a total strategic upgrade for the whole industry. Think about high-res audio files today. They're basically like a prints. They are infinitely copyable digital files with zero inherent scarcity. But with CSDL, we're turning audio back into a painting. It becomes a unique physical event that is directly authenticated and authorized by analog hardware. You're not just buying a bunch of data anymore, you're buying a genuinely scarce, uncopyable physical artifact.
The engine behind this is the E-warrant framework, and it brilliantly utilizes something called physical entropy. See, during chip manufacturing, the OTC arrays develop these microscopic, random variations. It's totally natural, but it creates a physical fingerprint for every single playback device that is literally impossible to clone. The E-warrant uses this unhackable physical reality to lock playback rights directly to that specific hardware layer. Now, for our manufacturing partners, you need to know this isn't some clunky DRM software that's going to annoy your users. First off, there's no software to hack. The security is at the physical layer. Second, all verification happens offline in the analog domain. No cloud connection required whatsoever. Third, if a collector wants to sell their vinyl, the E-warrant transfers safely on the secondary market, which actually creates a continuous revenue stream for partners via transfer fees. And finally, artists can create true physical scarcity. Imagine a museum-only edition that can literally only be played on specific, authorized hardware. To roll out a shift this radical, we obviously need a practical business strategy. So let's look at the three-phase rollout to gently introduce this tech to our partners in the audiophile market. We've mapped out a really smooth three-phase transition. Phase 1 is the artist sticker. The hardware verifies the physical fingerprint, but it doesn't limit playback at all. It's basically a premium badge of honor, proving your gear aligns with the artist's room. Phase 2 introduces timed exclusives. Here, core audiophiles with the right hardware get early access to that physical baseline for, say, the first month. It really drives that VIP early adopter value. And then Phase 3 is the full native license. Once the ecosystem is mature, we introduce fully binding E-warrants for top-tier collectors. This perfectly glides the market from a cool hardware perk into a fully IP-locked art collecting format.
Which brings us to this final thought. The creative moment is not a file, it is a physical event. By shifting from executing DSP code to relaxing physical hardware constraints, we're done just copying cold bits. We are literally recreating the exact physical space where the art was born, across both mathematical and physical dimensions. So the question is, are we ready to stop just listening to cold files and start actually experiencing that original physical event right in our own living rooms?